the involvement of the electric grid of Brazil, because it's a clean source of energy and cheap and non-polluting one, it will cause a problem from the point of view of operating the electric system. So what would I use from May until November in terms of complementary energy to prevent an imbalance between supply and demand, so not being exposed to hydrological risk? This is the results of the auctions from 2007 and 8, showing that there is a methodological issue in the auctions that's causing Brazil to include in its matrix diesel powers at 7,000 megawatts, GNL 2,000 megawatts, coal, and sugarcane bagasse for 114 average megawatts. So it's a methodological problem that is bringing a imbalance factor to the energy sector in our point of view. And we name this as a deficiency in purchasing the energy. This thermal energy are hired, or their power is purchased based on availability. They become available and they have a methodology that provides more competitiveness to them in the auctions when compared to bioelectricity, and where they are dispatched, which is done occasionally, because they are based on availability, the cost of fuel in terms of the cost structure of these plants is very high, because the supply chain of fuel works based on volume and not on the uncertainty factor. So when I need to include a thermoelectric power plant or natural gas, for example, each 1,000 megawatts, I need 5,000 cubic meters of natural gas. That's a lot of gas. So all of a sudden, ONS on Friday scheduled a dispatch for a plant for Monday. If it's a oil plant, the drivers become crazy without that extra demand. So this is something we find very serious as a problem in the current model, because I purchase the thermal power on an inflexible way that it is not competitive, because it cannot be included in the auctions, because the ICB methodology favors the plants that in theory dispatch less, but according to our analysis there is a great uncertainty as to the assumption of this probability of dispatch. And what we find necessary is to have agreements or purchasing agreements based on with the inflexibility based on season, where biomass would play an important role, because it allows for generation of bioelectricity precisely during the drought periods, the dry season. So the bioelectricity has a good electric potential. So this is the benefit I would have by bringing the bioelectricity to the matrix. So I would reduce the unbalance factor that's present during the dry season. So bioelectricity has a very positive complementary characteristic. We have been analyzing this data, and the preliminary results will be presented at an event that Cogem will make on June 18. I will be invited. We're just negotiating the fee. But at that event, we'll show the preliminary results on the findings on this research we're making. So bioelectricity is a renewable, available, and competitive energy. It's clean, is a result of another production process where value added is much higher, which is the production of sugar and ethanol. But when bioelectricity is generated, it can allow for purchasing agreements for 15-year term with a fixed price, which allows for a very good predictability. In this sugar and energy sector has difficulty to negotiate with the energy sector, the power sector, because they're two different worlds with rates that are completely different. The return rate on the power industry is safe. It's like a savings account. There are no ups and downs. So I would not have to generate more energy now to have a cash flow input, such as the sugarcane is doing for sugarcane industry, for example. Oh, now we're producing more ethanol, so they are crushing more and more to generate ethanol to have an extra cash flow, even selling, although they're selling ethanol at a lower price and even with a negative profitability rate. So the energy sector does not have this kind of thinking. You have to work on a different mind state. So you have to um, think that you're going to make less money but continuously and safely. To having a receivables of a contract of energy sale for 15 years, fixed with index to PCA, nobody's never heard of it. So when you're talking about hydroelectricity power, the contracts are for 30 years. So if you generate the power, you receive it. No problem. Bioelectricity is a 15-year contract because it's considered to be a thermal plant. So this potential and the possibility that exists for bioelectricity is large and is associated to the cycle of growth of production of sugar and ethanol, but it has to be seen with a different point of view, from a different point of view. So you can't think of it as you think of sugar and ethanol. You have to think of it from the energy standpoint. So it's a very clean energy and it's much more competitive. The only problem is with its competitiveness is because the methodology of the auction has structural mistakes that are built in. Okay, I'm running out of time here. This is a copy of the data to show this potential. And if you look at the auctions figures, and those who are from the energy sector are absolutely disturbed, and those from the economic area are even more concerned about it, because there's a potential that can't be made real because of structural problems in the methodology of the auction. So this can be done in a short period. All you have to do is to change the boiler, and that's it. I would have power available to be able to sign agreements for 15-year term indexed by IPC. We believe this is the right time to negotiate for both sides, and the development of a technology that's the DIN is responsible for. So it's one of the main company that produces capital equipment or fixed equipment. You probably saw that BP is now going to invest in the second generation ethanol, but we think that the cost of that technology must be so high that it probably won't be scalable for companies, for mills that need a retrofit currently with the 21 bar boilers. So we have a possibility of transforming such boilers from 21 to 60, generating extra power, executing specific agreements, and making this growth feasible instead of making such a transformation with a TIR from ethanol and sugar industry. Then it would be unfeasible. And my last slide, or one before the last, was the challenge is the increase in competitiveness of the auctions. We believe there should be specific auctions because the bioelectricity is not competitive within the current the way the current auctions are set up. And usually when we talk to anyone, people say these people from the sugar mills, they want to make a lot of money. So they're two different worlds. The world of TIR, ethanol, and sugar, where there's risk because prices go up and down according to commodities, and the world of electricity, which is risk-free. So these two worlds have to come to an agreement according to our point of view. And there are conditions for that. Funding by BNDES, there is a demand for electric power, and the energy matrix exposed at the auctions, which is a Kafkian situation. And as we saw in an article, we never do an auction at the middle of a crisis. So, what's missing? That's the question you are supposed to answer. Now, I'm going to go into the conclusions, which summarizes the assumption in the first slide. Our matrix is in a transition stage. It needs a complementary energy source. If these diesel thermal power plants are called to operation in June, August, we won't be able to pay the bill. They operate a very high cost. And we think that bioelectricity could cover this possibility very well, given the features that we presented here. And finally, I show a slide with my name, email, a Google address. We have several articles on the subject, and I have written a lot on bioelectricity, including a book we finished in September last year, which is available at the main bookstores. And I like to give you my mobile phone in case anyone feels like asking some urgent question during the day. Thank you very much for your time and attention. Thank you, Professor Nivalde. I think informations are complementing each other here.